Find the volume of the solid obtained by rotating the region bounded by the curves y equals 2x and y equals x squared about the y-axis. So we got this region, this straight line, this one. The top curve is y equals 2x and the bottom is y equals x squared, and these are not in proper scale, as you can see, 0, 1, 2, here 1, 2, 3, 4. Anyways, these two curves intersect at the origin and at x equals 2. Okay, that's 2 and y value is 4. Okay, this point is in fact 2, 4. Now we have this region shaded already and we want to rotate this about the y-axis. So this is y-axis, so we are rotating about this one. Okay, generally we try to use vertical slice because then our integration will be in terms of x, and as the curves are given y equals x, y equals x squared in terms of x, so a vertical slice makes more sense here. If we do vertical slice here, I mean the generic point we don't have to write, but this would be x, that's the generic x, comma, height is given by the curve x squared, and this one would be generic x and y is 2x, so this point would be then x comma 2x. Now if we rotate this about the y-axis, okay, so we have a slice rotate about this axis, that means we're gonna get a shell of a cylinder. Okay, so in this case, so let me try to draw. It does not have to be perfect. In fact, you don't have to even draw this. Okay, so it's not easy to draw for some people, so you don't have to draw, but this would be the shell of a cylinder. In this case, all we need is the surface areas that is given by 2 pi RH. Okay, so the volume is given by 2 pi RH. So let me figure out the radius and height of this shell. So from the center means y-axis here to here, that's the radius. So this horizontal distance is the radius, which is in fact generic x. Look at this point, x squared. So r is simply x. Now the height is the slice, the length of slice, okay, this height. That is the difference of y coordinates. So the upper curve 2x minus lower curve x squared. So this height is in fact upper curve minus lower curve. Okay, that's the height. Then now we can find the volume by the formula, that's 2 pi RH. We can put 2 pi outside, r and h. So r is x times 2x minus x squared, and with respect to x, now we need to look at the ranges. Okay, this slice for the x, it can be taken anywhere here to here. Okay, this slice could be here or here, anywhere, so 0 to 2. So the limits for x 0 to 2. Now this is simple integral, we can easily evaluate. Let's do it. 2 pi outside, let's distribute this x inside here, and we need to integrate afterwards, because for the product we cannot integrate as it is. Okay, you cannot just find the antiderivative of x and antiderivative of this one. There is no product rule, so we must get rid of this product. X times 2x is 2x squared, x times x squared is x cubed. Now we have two terms, let's integrate 2 pi, and these limits are now 0 to 2 there. So inside 2x squared, 2 is 2, antiderivative of x squared is x, 2 plus 1 3 divided by 3, minus x cubed, x 3 plus 1 4 over 4. Okay, now let's plug in upper limit 2 minus lower limit 0. So 2 pi is all the way outside, upper limit part minus lower limit part. 2, plug in 2, 2 cube 8, 8 times 2 16, okay, 16 over 3 minus 2 raised to 4, 16 over 4 minus lower limit 0, 0 cubed is 0, so this is 0 minus 0, so there is no contribution. Now this is 2 pi, okay, we just subtract, and we should not be writing decimal number, but 16 thirds minus 16 fourths, this is 4, but let's do this, okay, 16 16, from these two terms we can factor out 16. I mean, you can do your way to simplify this one, okay, 1/3 minus 1/4, 1/3 minus 1/4, so 32 pi, so 3 times 4, 12 is the common denominator, 12, 4 times 1, 4, minus 3, 4 minus 3, so this should be 1/12, okay, which is in fact, what is that, in terms of a nice number, 4 goes 3 times, 4 goes 8 times, so 8 pi over 3 cubic units, because this is volume. That's the final answer.